This is Algebra 2B, Statistics Lesson 6, Correlation. So, correlation is how we are going to measure the relationship between two variables. If two variables are correlated, that means we can predict, right, one with the other. Generally, we're going to do that with a line of fit. So when we have a line of fit, like if we have a scatter plot and we have our x and our y, we can make predictions based on that line of fit. We need to have an even number of points above and below. And we need to make sure that our line follows the direction of the points. So let's talk a little bit more about correlation. So correlation can be positive or negative, or it could also be zero. A positive correlation means as x increases, y also increases. And that would be the example that I drawed for line of fit, right? When x increased, y also increased. A negative correlation would be as x increases, y decreases. And I'll draw an example in some of these boxes here. So a perfect correlation would be if we had a scatter plot and every increase here was exactly fitting our line of fit. So let's pretend that I can draw really well. Every single point here would be right on the line. That is a perfect positive correlation. We use something called the correlation coefficient, R. That would be 1 in this case. And you can kind of think of that like 100% of these points fall on that line. Okay? A really strong correlation would be, we have some increases here and they're pretty tight on a line, but not exactly on a line. And then a weaker correlation would be, yeah, there's a definite upward trend, but the points are a lot more spread out, right? So this might happen when our R value is maybe between 0.5 and 0.5 and 1. I'm going to move him over a little bit. Come on. Did I miss it? Okay, so if our R value is kind of between 0.5 and 1. This would happen if our R value was between 0 and 0.5. And so without having numbers, without having exact data points, I'm just making an estimate based on how close those dots are to the line. But if we wanted to calculate correlation, we could do that and get the higher it is, the closer it is to 1, the stronger it is, versus the lower it is, the closer it is to 0. For negative correlations, they're going to do almost the exact same thing, but our dots and our lines are going to follow a downward trend. They'll have negative slopes instead. So this would be R equals -1 if every single one of those points, right, if I was a better artist, fit exactly right on that line. That is an R of -1. It's a perfect downward trend line. A strong then would be, again, we have our points and they're obviously going down, but not necessarily right on the line. Our line of fit should have, like we said, an even number of points above and below, follow the direction, the trend of the points, right? This would be if our correlation was between -1 and -5. So, and then a weaker but still negative correlation we're going to have an obvious downward trend of the points, but they're going to be a lot more spread out, right? A little further from the line. That would be a weaker correlation. So we're going to go, our R would be between 0 and negative 0.5. Now, I gave 0 its own category. If you are looking at your points and you can't tell if there's a line going up or a line going down, right? Your trend is actually kind of going to be flat. We really can't tell if there's an upward trend or a downward trend to the data. There's no obvious line of fit that we can fit to this. That's no correlation. They're not related. Okay, some examples. Estimate a correlation coefficient for each scatter plot. So if I'm looking at scatter plot A, I don't really see a good trend line there. It kind of looks like it's going down here, but then it kind of looks like it's going up here. So the trend would actually kind of level out. So our R would be pretty close to 0. You might say, you know, maybe it would be a negative 0.1 because there's more points going down than are going up. So I'm going to do that, negative 0.1. It's almost 0, but I do feel like it would be a little more negative than positive just because there are more points going down. But R of 0, R of negative 0.1, those both seem good to me. If I'm looking at scatter plot B, it's not a perfect line, but it's really close. So I would probably say my R would be 0.9 on this one. Almost every single dot falls on that line, so almost 100% of those points. And I mean, we can go more degrees of accuracy, like I could go 0.95, 0.96, but I'm going to just estimate it's about a 0.9. If I'm comparing scatter plot B to scatter plot C, they both look pretty good, pretty strong, but I would say B is just a little bit stronger than C. And I would also say because B was pointing up and C now looks like it's pointing down, I'm going to give this one a negative. Not as tight as B, so I'm going to say negative 0.8. And again, I'm just making estimates based on the picture. I would need to have data, points, numbers, right, if I wanted to actually calculate the correlation, but we're not going to bother doing that by hand. We're going to just use some technology tools to do it for us. And I'm looking at scatter plot D. If I'm looking at this, to me, it looks positive. And it was because of these couple high leverage points over here. If those weren't there, it looks pretty flat, but because these are kind of lower and this one's kind of higher, I do think it looks positive, but I don't think it looks very, very strong. So I'm going to give this kind of a weaker number. It is a positive, but I'm going to say maybe 0.2, 0.3. And finally, E. E doesn't look like it has any upward or any downward trend. I'm going to give that one a straight 0. Example B. The scatter plot shows ice cream sales, X, and visits to the nurse to treat sunburn, Y, at a certain summer camp. The line of fit and correlation coefficient are also shown. So I can see my R value right here, 0.866, almost 0.9, tells me that this is highly correlated data, okay? Highly correlated, strong. Correlated. Strong. That means I can use this trend line to help me make predictions, okay? We said anything higher than 0.5 is actually pretty strong, and almost 0.9 would be very strong. So the question next is, do ice cream sales cause sunburn? So the more ice cream that gets sold, the more sunburn we see, but there is no causation with this, right? Ice cream doesn't cause sunburn. We have what we call a lurking variable, a third variable that causes both ice cream sales and that causes sunburn. And examples would be maybe temperature, or maybe sunlight, right? If it's hot outside, if it's sunny outside, we are more likely to crave some ice cream. We are also more likely to get a sunburn. So these are our lurking variables that might be causing sunburn, that might be causing ice cream sales. Just because we have a correlation between them doesn't mean that there is causation there. Variables. Okay. Letter C, use the line of fit equation to predict the number of sunburns treated if $150 of ice cream is sold. So I know that X is my ice cream sales. So I'm going to plug 150 in for x of my equation right here. So we'll go 0.27 times 150 plus 12. And I'm going to go to my calculator. I can type that in as long as I have my parentheses or times. It will do the same thing. So I can predict if $150 of ice cream is sold that I should see about 52, maybe 53 sunburns. I'm going to round that to 53 sunburns. And now I used the equation to do that, but we probably could have also used the graph to do that. 150 would have been right in the middle, and I can get an estimate by going up to the line and out to the scale. Now that's an estimate. I know it's a little higher than 50, but I wouldn't know if that was 53, 54, 55. That's why I like the equation to be a little more precise. And our last one, use the line of fit to predict ice cream sales if there are 200 sunburns treated. Okay, so again, I'm going to use the equation to do this. My graph doesn't even go to 200, right? I stop at 140 on my graph. So if we had 200 sunburns way up there, that's going to be my y. I'm going to sub 200 in for y, and then we're going to do just a standard linear solution. 200 is 0.27x plus 12. So we're going to minus 12 from each side. Whether you like that equals 200 in the front or equals 200 in the back, it's not going to make a difference. So that gives me 188 equals 0.27x. Next, we want to divide both sides to get rid of the number in front of x. And that's not one that I'm doing in my head. 188 divided by 0.27. It looks like we made $696.30. That's a lot of ice cream. A lot of sunburns too. Looks good. That is it for this lesson. Good luck on the exercises, and please let me know if you have questions.